Today we started to learn about triangles and how we can work with triangles when they are in the coordinate plane. Our first job today was to find the perimeter of a triangle, and we did that using the distance formula. Our next goal will be to find the area of a triangle. So we need to remember what the formula is for the area of a triangle. In order to find the area of a triangle, we need to multiply 1/2 times base times height. We can find the length of the base of the triangle. That's just using the distance formula that we used today. But in order to find the height, we need to find the height of the triangle so that the height is perpendicular to the side. And so we need to learn about what it means to be perpendicular today and how you can determine if a line is perpendicular to another line. If I want to find the area of this triangle, I would want to multiply 1/2 times base times height. So for example, if you decide that the side on the bottom, square root of 17, with that length, square root of 17 was going to be the base, you would need to find out how long is the height. But it can't be a height unless it is perpendicular to the line at the bottom of the triangle from 1, 1 to 5, 2. So our goal is to figure out how can we come up with this line, which is perpendicular to this line. And that's going to take today's video, entire video, for you to learn and understand that concept today. The key idea for today's lesson is that lines that are perpendicular have slopes that are negative reciprocals. What does that mean? Well, I hope after you look at the next few examples, you will understand what that big, long English sentence means. Lines that are perpendicular have slopes that are negative reciprocals. We're going to look at this line, and this line goes between 0, 1 and 2, 4. And if I wanted to find the slope of that line, I could put those points into a table. And if I did that, I would see that the y's are jumping by 3 and the x's are jumping by 2. So the slope would be 3 divided by 2, which makes sense since if I want to go from this point to this point, I'm going up 3, I'm rising 3, and I'm going across 2. So my slope would be, here's jumping by 3, here's jumping by 2, so my slope would be 3 over 2. What does it mean to be a negative reciprocal? It means that since this slope is positive, if I want to find the slope that is perpendicular to that one, I want to change the sign. So if it's positive, I'm going to make it negative. And reciprocal means I want to flip the fraction. So I'm going to make it negative 2 over 3. These two slopes should be perpendicular to each other. Let's check. This is slope number 2, and this is slope number 1. Let me show you on our graph. So, for example, if I was to start at this point, and I was to go down 2 and across 1, 2, 3. If I went down 2 and across 3, this would get me to the point 3, negative 1. I'm going to connect those 2 points, and we're going to look to see if that looks perpendicular to our original line. I've connected the points. I've connected the points from 0, 1 to 3 minus 1, and that certainly looks like they are perpendicular. And perpendicular means they form a 90 degree. So let's just look again. If I made a table from 0, 1 to 3, negative 1, from 0, 1 to 3, negative 1, this is going down 2, this is going up 3, so my slope is negative 2 over 3. So slopes are perpendicular to each other. Lines are perpendicular to each other if their slopes are negative reciprocals. My first slope was 3 over 2, and my next slope for my line that is perpendicular is negative 2 over 3. That is a big idea. So we're going to look at that idea and see how it relates to our triangle, which we looked at in yesterday's video. We're back at our triangle from yesterday, and I've decided that I'm going to make the base of the triangle this line segment that goes from 1, 1 to 5, 2. And I want to find the slope of that line. So to find the slope of that line, 2 minus 1 is 1, 5 minus 1 is 4. My slope is going to be y2 minus y1 over x2 minus x1, which is going to be equal to 1 over 4. So the slope of this line is 1 over 4. That means the slope of my blue line, if it's going to be perpendicular, the perpendicular slope, my next slope, should be the negative reciprocal of this. So that means instead of being positive, it needs to be negative. And instead of being 1 over 4, it should be 4 over 1. This slope right here, it is decreasing. You can see the line segment's decreasing, and it's decreasing steeply. So this line segment right here should have a slope of -4 if it's going to be perpendicular to our base, which had a slope of 1 over 4. Things are going to get a little bit more tricky because what we want to have is we want to find the equation of that blue line now. We know it has a slope of -4 over 1. We know that blue line has slope -4 over 1. What we want to do is we want to have the equation of that line. So the blue line is going to have this slope, but I know that the blue line has to go through the point 3, 5. I've got this blue line, I know the slope, and I know it goes through that point. We've done this before. I'm going to move to my next piece of paper, and I'm going to do some math to find the equation of that blue line right now. So I'm going to take that blue line that's on my triangle, or in the height of my triangle, and I'm going to draw it again on this piece of paper. We know it goes to the point 3, 5. We know it goes through 3, 5, and we know it has to have a slope of -4 over 1, or -4. So let's put that in a table. I know that it goes through 3, 5, and it's going down by 4. That means at 2, it will be 1. Oops, no. At 4, it will be 1. At 5, it will be -3. At 6, it will be -7. It's going down 4. If I wanted to go backwards in my table, that means at 2, it would be 9. At 1, it would be 13. And at 0, it would be 17. So that means, I know you can't see that on this graph, but that means I would have, my graph would be, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Here is 17. So my line would start at 17, go down 4 each time until it touched 3, 5. I realize my work is a little messy, but I can see that the initial value, or y-intercept, is 17. It's going down 4 every 1. It goes down 4 across 1, down 4 across 1, down 4 across 1, and it ends up touching 3, 5. It goes down 4 and across 1, goes down 4 and across 1. So now I know that the equation of this line, which is also the height of my triangle, is 17 minus 4 every time, or it goes down 4 every time, and it starts at 17. That is my equation of this line. This line right here, this height, has equation y is equal to 17 minus 4x. Now, it'd be great if I found out this equation for this line, because then I could find out where the blue line and the base intersect. So I could find this point right here. Because once I know this point, I can determine how long the distance of this line segment using this formula. And then I can find out how big that height actually is. So I have the equation for the height. Now I need the equation for the base. Now I know, remember, my base, it had slope 1 over 4. So how could I find the equation of that line? I know that it has slope 1 over 4. Y is equal to mx plus b. I know my slope, I just don't know the b value, but I do know it goes through 1, 1, so I can put my 1 here and my 1 here. 1. Okay, So then I have 1 is equal to 1/4 plus b. And that means that my b is going to be 1 minus 1/4. My b, get a common denominator, is going to be 3/4. Which means, and this is a lot of math, this means the equation for the line, which is the base, is y. It's going up 1/4 every x. And it starts at 3/4. Let's make sure that makes sense. If I extended this line, oh yeah, it looks like it might start at 3/4. That seems very reasonable. My initial value or my y-intercept would be 3/4. Now, our last thing we need to do, and this is a lot of math we're doing right now, we need to find out where does the base and where does the height intersect. Because once we know where the height and where the base intersect, we will know the value of this point right here. I've moved to my other piece of chart paper. This is the line which represents the height. This is the line that represents the base of the triangle, and I want to know where those two intersect. So I'm going to have to do some algebra. I want to know, when does 17 minus 4x, when is that equal to 1/4x plus 3/4? So I'm going to do some algebra. 1/4x plus 4x. I'm going to move this over. And then 17 minus 3/4. And here's a little trick. Anytime you have an equation with fractions, what you can do is you can multiply all 4 parts by that bottom denominator. If I multiply everything by 4. Multiply everything by 4. The nice thing about that, 4 times 17, I need to do some mental math, 68. 4 times 3 divided by 4 is just minus 3. And then 4 times 1 divided by 4 is just x. And then 4 times 4x gives me 16x. So I get 17x. And here's 68 68 minus 3 is 65. So that means my x is 65 over 17. This x value right here is 65 over 17. So we know the x value. Now we want to find the y value. To find the y value, all I need to do is I can pick either one of the equations, put that x into the equation, and I get 17 minus 4 times 65 is going to be 260 over 17. And then I want to simplify that fraction, and that fraction will tell me the point of intersection right here, where the base and the height intersect. Now, that is not easy math. This is challenging stuff. What I want you to do is I want you to try the same math for the questions on your worksheet. And I promise we will talk about it together and I'll answer your questions, but let's try using what you learned in this video and apply it to your questions from your worksheet.